So in my part of presentation, I am going to give a technical overview of the use case that has been just shown to you. So without wasting much time, we'll get started with the actual action. So let me go there. So basically what we have is actually a fleet of trucks which are connected with the sensors. These sensors actually measure the state of the truck and which actually implicitly gives us the state of the items that are transported using that truck. Now these trucks have different kinds of sensors. So we can have a location sensor, we can have a speed sensor, it can have also the temperature sensor or the fuel sensor. So all these trucks are fitted with different kinds of sensors to keep the track of all the measurable, I will say, information from the trucks. At the same time, the GlobalLogic can also have the sensors fitted within the store. So these sensors could be, again, the same type of sensors or similar sensors, or their sensors could be like, what we say, a motion sensor or any other sensor could be there. And the farm also is fitted with different types of sensors, again, so we can have a weather sensor or a humidity sensor or a rain, whatever. So different kinds of sensors are actually attached to each and every entity within the system. So now these sensors are actually collecting the data from their physical environments. Now, once they capture the data has to be stored somewhere and processed, so that we can make some decisions after analyzing the data. So all these sensors from different, like from farm, from GlobalLogic and from the trucks, actually send the data to the platform, which is in the cloud in our case. And this data gets actually stored also in the cloud, and then it gets transformed and analyzed within the cloud. So based on the data, we may be sending some alerts around. Let's say a truck goes out of compliance, an alert may go to the store manager or a farm manager, telling him that this truck is going to out of compliance. So we need to either redirect it or send a new truck so that the containers can be exchanged. Now, whatever data we store right now in the platform, that actually needs to have applications, because you may have application for store manager, for a farmhouse manager, you can have application for a driver. So they all use the data which is in the platform, and these applications are actually exposed via, in our case at least, via web services to these application developers. So the application developers actually use the data which is stored in the platform and extend it to implement a business flow based on the end user. Now, if we look a little bit deeper into this high-level technical architecture which we have, because we want to identify how we deal with this. So this is a very high-level architecture which I showed earlier. Now, if we look at this, that we have the trucks here. Now, trucks are fitted with the sensors or devices. Now, these sensors inherently have very limited capability in terms of resource which they have. When I say resource, I mean to say the processing power or the memory size which they can actually hold. So that way, this all these sensors actually are constrained in their communication, which means that they cannot communicate beyond a certain, I will say, beyond a certain limit. So that's why what we actually define the network, which is actually the network of the sensors. So we call that it is within the constraint network. Now the constraint network is the network which has a limited capability in terms of the data that it can actually send across. So like we have a Bluetooth or Zigbee or these kind of various technologies which are used at that point. But these technologies have been specifically they have been specifically designed for these kind of devices only. The devices with low memory and processing powers. Now, if you see then, and everything else outside this, so you have this what we call an unconstrained network. So these are the networks which theoretically can actually have unlimited bandwidth. So they can send the data irrespective of the size of the data. So they are capable of handling any amount of the data. So after that, we have the platform. Now, platform, if you see, now when we are talking about the IoT, so in the IoT, we always start with at least hundreds of thousands of devices if we do. So even in the reference architecture which we have built, in that in our 0.01 release, the target which we were actually focusing on was at least 100,000 devices per second. So that's the kind of volume which we are starting with, and it's very minuscule. Actually, we are targeting at least 6 to 7 million devices per second. So the scalability is a very serious concern when we talk about the platform. And in case of applications, the challenge lies in the versatility of the applications, because you have applications which are built for various platforms, and you will have applications which are built for various devices or different types of devices with different screen resolutions, and you have applications which are built for different types of end users. In our case, we have a different application for a driver, a different application for a store manager, and a different application for, let's say, a farm manager. And definitely, there will be different types of applications for the management of that store. Now, okay, now let's. So if we see here, when we talk about constraint network, as Jim has already mentioned in his presentation, that the technologies are there. So you will see why we are saying the technologies are there. Because when we talk about constraint network, we know there is a paradigm, because all of you I'm assuming that all of us are technical, so that's why I'm not getting into details of each and every technology. So we have machine-to-machine paradigm, which has been always there. When I say all, it has been actually there for quite some time. And so these technologies are actually used for communication within a constraint network. So whenever you have a constraint network, the technologies which we apply there are bracketed under the machine-to-machine technologies. And then we have the technologies when we talk about scale. So all of us know that the cloud technologies are very good for scale, virtualization and horizontal scaling and stuff like that, which has been used by the big companies, whether we talk about Google, we talk about LinkedIn, or we talk about Twitter or Facebook. So they all use the technologies which are cloud-based. And the analytics also is a technology which has been around for quite some time. Definitely we need some innovations in these technologies, which actually has already been brought by the big data concepts which we are using. So the big data technologies are already available there. There are a lot of tried and tested technologies which we have in the big data space. And same technologies are extended to the big data analytics also. And then when we look at the applications, we have mobile and web technologies which have been around for years. So, and these technologies are very mature. Now, if you look at these things, so I am sure all of you, so there is nothing new in this. Everything was always there. So what is new about IoT? I remember people asking when we were in the cloud, that Hive time, what is new? Well, virtualization was always there. The hypervisor was always there. It has been there for decades. So why suddenly we are talking about it? So it all depends on what you need at what point of time. So since the business got interested into the cloud and the virtualization, and they saw the benefits of the virtualization, so that's how it became popular, because business started investing in that. So same way, this is happening with the IoT. The technology is there. So what we need to do here is that we have to actually glue them together. That's where the challenge lies. How do you connect all of them together and then present the end solution? And also the challenge here lies also when we talk about technologies, that these are completely separated domains, technical domains. The M2M guy rarely actually works with the, with the cloud and analytics. And the cloud analytics guy is hardly, you will never find a cloud guy actually creating a UI or creating the applications for a iOS or for an Android device. So that's the challenge. So the challenge is to actually bringing everybody together. So that's why when we actually continue with this session, you will find a lot of us actually coming on the stage and talking about their components. Because it's not possible for one person to actually have all the information about all these technologies. So this is the challenge actually which IoT brings when we talk about development. You need a completely different set of people with different skill sets to actually execute an end-to-end IoT platform. And fortunately, we in the GlobalLogic, since we work with multiple projects, so we have this kind of a capability where we actually have people expert in their own domain areas, and then obviously there are people, senior architects, who actually then sit together and come out with a solution on those lines. Now, what I want to bring also is that since most of us here may be architects, so what we are always interested in is that when we build a system, we need to know what should we take care of. So what are the architectural concerns and what are the design considerations that we have to keep into that we have to actually keep into consideration when we are building an application. And that is all where the experience comes in. So it's not possible for a guy who actually works on analytics and then suddenly think about IoT and tell how to handle the M2M part of it and how to handle the application part of it. So, and there has been a lot of research, a lot of papers have come out. That's how we have come up with the conclusion, like what are actual challenges which one has to consider, other than the traditional challenges which are there when you are actually designing an application like IoT. And if you look at the glow mart also, now glow mart, okay, could be let's say we have a mart which may have hardly hundreds of thousands of sensors. But if you look at a Fitbit kind of a device, which is a health device, so it's a mass device which can be purchased by anybody. So you can have actually millions of devices which are out there. So how do you support the IoT for that? So the scalability is always there as a challenge, but I don't see it as a big challenge in the terms, because we already have a lot of technologies out there which are able to handle decently the scale problem, especially in their horizontal scaling. And Google and Yahoo kind of companies have done a lot of work on that. So there we are to some extent safe. Yes, we have to innovate more on that, but we can say at least we can get started. But interoperability is a challenge. Now it's a challenge, I will not say at the cloud layer, but it's a challenge at the M2M layer. Now why interoperability is a challenge? Because we are talking about connecting devices, or what we call connecting things. Now things do have the different, so you have a Sony, you have Samsung, you have Texas, you have Philips, so all of them are actually building these things which we want to use. And as of now, none of them is following a standard protocol. So that's why the interoperability becomes a challenge. Like how do these things can actually talk to each other if they want? That's why the challenge lies. So you have heterogeneous systems and as well as distributed resources. So your resources are very distributed. And the other challenge is extensibility, because when we talk about things, we talk about things which were there and the things which are going to come. Now when new things are produced, so new opportunities come. So there are people who come up with the new and innovative ideas to actually make money out of it. So what we have to make sure is that how do we keep the architecture that we are going to come up with, especially with regards to IoT, extensible. It has to be extensible. It's a very serious problem in the IoT, IoT architectures, when we talk about the building an architecture. So resiliency is again, so especially resiliency in terms of network partitioning and kind of system errors, because if we are having let's say a critical path, or we are having medical devices, so as was just mentioned that there was a blood pressure which has actually gone beyond a certain limit, and the person was not knowing about it for some time. Now, well, that's a serious problem. So let's say if the connection is not there, so what will happen in that case? So are you going to wait till the connection is going to actually again restore, and then only we actually inform the concerned people around it? Well, no. So we have to take care of this network partition as well as disconnected architecture. So we need to have a disconnected network architecture. Those things have to be in place. How do we handle those kind of scenarios? And performance, it becomes a serious problem here, is because we talk about near real-time processing and high processing. It's high volume processing. So near real-time processing is like actually, as Jim was mentioning, that we need to have what differentiates IoT from the other, from the simple analytics or predictive analytics kind of applications is its capability to take decisions near real time. Now that becomes a performance issue. Now we are talking about near real time, not as a small what we say real time operating systems. We are talking about real time for the terabytes of data, because you have to. So in the gyms, that Lambda architecture, we have the deep insights. Now these deep insights also has to happen real time. So there could be decisions which we have to make near real time. That's why the performance also is a challenge there. Now security, everybody talks about security when we talk about IoT. And then I have a lot of people actually talking to me, security was always there. Why it is special, why we are focusing so much on the security of the IoT? We can just do encryption and stuff like that. But the problem here with the security is the privacy, because these things actually define us, we as humans. If you are at home and you have a connected home, which means that everything is connected, if your privacy or if your data is compromised, actually anybody can then figure out your activities within the home, what you are doing, what time you are inside the home, when you are going out of the home, and things like that. Or let us say the privacy of medical records. So especially the IoT has seen a lot of implementations I think for quite some time, I have been involved with many implementations where we are trying to implement the devices, medical devices. That's where we have seen a lot of implementation as of now in the IoT. Now, in the medical devices thing, your medical history should not be exposed to anybody other than your doctor or whoever is the concerned person. So this kind of privacy issue has to be there. So because the data, when it comes from you, it comes with your information. So how do we handle that privacy? How do we make sure that this data, the data which belongs to what we say private information, which is very private to you, should not be exposed or should not be stored or whatever we want to do with that. And deceit is also very important, because somebody can actually impostor you and present you as somebody else, because you are not physically going and putting some kind of a physical presence at any point. It's all virtual. So IoT is all virtual. They are all virtual representation in the what to say, in the internet. So that deceit could be there. And then the maintenance obviously is like maintenance of things and the platform. How do you maintain these millions of devices? How do you update their software? How do you update their firmware? And how do you control all those things? So these kind of challenges which though we find in other systems also, but here these non-functional challenges are very important to IoT, especially on the areas that I have actually mentioned. Now, when I talk about design considerations, so in the design considerations, we are talking about identity management. So in the identity management, we mean to say, how do we identify the things and how do we identify the people? Now, things, why it becomes a challenge? Because if anything becomes part of IoT, it needs to have an identity of its own. Because that's all what we want to do through IoT. We want to give everything an identity in the inverse. So how do we manage the identity? How do we come up with these, what we call as global uniquely identifiers, for what kind of algorithms we are using? So there's work actually happening. How do we identify a thing in IoT? And also the identity of the people. How do we define the identity of a people? In today's world, one person has multiple identities. Even if you have one identity in the Twitter, you have another identity in the Facebook. So how do we manage these identities? So and even the context awareness. So you will find this whenever you see any IoT website or any IoT technical paper, this context awareness is something which is always highlighted there. This is a challenge. Now, why it is a challenge? Because every data which comes from the sensors has to have a context associated with it. So let us say I have a glucometer and I am checking my glucose levels. So the context has to be given there. The context is Sohail, whose data is coming. But at the same time, let's say you have a blood pressure machine, measuring machine. Now that machine can be used by multiple people. So in a house, so more than one person can actually be using the same machine. So how do you make sure that, how do you actually identify that who is using at what point of time that? So these are challenges. Even there is no clear-cut answers, even though we are working on the IoT, but we still don't have very clear-cut answers how to handle these kind of scenarios. And obviously the answer is always from us, it depends. So now the location again is very simple, so everybody wants to know the location of things. Now data generation mode. You have to also consider when you are getting the data from the IoT or from the sensors, we have to keep into consideration how the data is going to be generated by these sensors. Now we have event-driven and time-driven. Now event-driven is that, let's say we have a door here and we are opening the door. So there's an event happening. The opening of the door is the event. And the data could be generated at that point of time by a door sensor. And there is a time-driven event. It's like a time series event. Like we are measuring the temperature of the truck. Now this temperature of the truck is not an event happening. It is an information which is being sent to us in the intervals of different times, which is like every 5 minutes or every 10 seconds or whatever. And then the thing capability is the most important thing. It's about processing power and the memory size, because this thing what we are talking about actually brings us the most challenges, because their processing power is not what we have in the mobile phones also right now. Their processing powers are very limited, and your the memory sizes are also very limited. So how do you handle your program in such a way that you should be able to keep those things also part of your IoT solution? And then we have forward and backward compatibility. Well, it's again the challenge here, because now we have heard of these terms very often, but they have a special meaning here. So here they are really serious challenges. It is not that you start writing the code first day, then you will say, I will think about when I will do the backward compatibility. Here it is the day first work you have to do. In your architecture, in your design, this is the first thing what you do. How do you manage the backward compatibility of the old and new things? Because you are again talking about millions of things. So you are not going to discard the old things and just support the new things. Or if the new thing comes tomorrow, how you are going to support that? Now I am just showing you the reference architecture which GlobalLogic has developed in-house. Now you don't see the, actually it's kind of obfuscated because we have not decided to go public with it yet, but we may go soon. Now in that what we have done is actually we have identified various high-level components. That's what we are showing, but there are a lot of obviously sub-components in each of these high-level components. So in that you can see that on the left-hand side we have M2M device and internet gateways. So this is what takes care of your sensors. You can see there are sensors there. So and then there is a gateway here. And then we have something called what Jim was mentioning in his Lambda architecture. We have something called fast decision making, where the data when being collected from the sensors gets processed in the near real time, and then they actually get then we apply some business rules on top of it, and based on the business rules we can actually throw the events using the notification system. So let's say there's a truck which again as in our use case we mentioned that the apples so are actually getting over from the cabinets. Now how do we fill that? So you get alert, somebody gets an alert that tells him, the driver, that okay, we need to get a new we need to get more apples for the store. And then all this decision making is actually taken care by the historical information. So the historical information is the information that we store over a period of time. Now here why it is important, because you are expecting around at least a terabytes of data per day or per week. Now your analytics actually is taking care of all this data in the near real time. So how do we process this kind of data? This is a challenge. And the deep insights is coming from that basically. And then you have platform functions. These are actually the services that we expose, our platform exposes for the applications to use for the consumption of the applications. And then we have something called complex actions. These are the actions which extend the platform basically. So what happens that maybe the platform is able to perform some basic functions, but what we do here is the complex actions is actually we can have some workflows happening, like when let's say there's an event which says that the temperature of a cabinet has gone across a certain limit. So which can actually start a workflow. The workflow can be actually invoking or sending a message to a service center which will tell him that there is some problem with the system. Also sending a message to the store manager telling him that, hey, get the apples out of this cabinet because there's a problem with the cabinet. So this is a workflow which can be built around it. So that's and then there's the end user management and clients. So it's actually how we manage the platform, and also some inputs what we get from the users for the platform. So this is basically our reference architecture. So we'll be giving you more deep insights into this reference architecture by other team members. As I said, we have specialists in every part of the IoT, whether it's M2M, cloud, analytics, or the applications. Okay, so you'll have to bear me for some more time. Now, this is the first part of our reference architecture, which you saw, which is the M2M. So I'm going to talk about how machine-to-machine communication happens in the IoT, and how it actually, what kind of functions it has to perform, and stuff like that. And machine-to-machine is, I will say, is the essential component of any IoT solution. I will not say essential. I will say it is a fundamental layer for any IoT, because that's where from all the data comes. And okay. Okay. So when we say IoT, we actually say IoT as network of physical objects. That's what we actually mean by IoT. We never mean IoT like a virtual objects. When we talk about physical objects. Yes, those physical objects are actually represented virtually in our system. But when we say is a network of physical objects. And so how do we handle this? How these physical objects become part of the become part of our IoT platform is by having what we say sensing and interacting embedded technology. So we have the technology in place at the MTM layer which actually are able to sense, let's say, environment, get a temperature of a room, or get the speed of a truck. So truck is a physical object, and these sensors actually are one who gives us information on the state of that thing. So that they played the primary role in this paradigm, what we are talking about. Now same thing, then the other functionality or other function, not functionality, the other function of this MTM layer in this whole IoT solution is to have a secure communication capabilities, which means that objects which I said, the sensors which are part of the, let's say, truck, now how do these sensors actually communicate with each other? So we have to give them a secure mechanism to communicate each other. That's very important in the IoT. And the third part is interoperability that's talking to each other, which is like how do these devices actually talk to each other? Because when we humans talk, we need to understand each other's language. If I'm talking English, I'm sure all of you will be understanding English. If I talk about in some other language here, which none of us understand, then the communication is not going to be bidirectional. So we'll have issues. So that kind of interoperability is a challenge here. The challenge is because there's a Samsung which builds an embedded technology in their own way, and then there are other companies like we have a Texas Instrument which has their own firmware and building those applications. So how do we make them communicate with each other? Because they don't understand each other's language. Now, if we talk about the sensors, the first part, which is actually the real-world interaction, so that, as I said, is provided by the sensors. And if you want to have control over, let's say there's a door, now you want to open and close a door remotely. So you need an actuator for that. Actuator are nothing but what we call is kind of a motors, stepper motors. So you need an actuator there, which actually is going to open or close a door. So these are actuators. Sensors are something like where you want, if I am moving on the stage, so I will have a motion sensor here, which will tell him, oh, he has already moved maybe 100 times from here and there. So these are actually the sensors. Now we have machine vision and human interaction and other systems. So these machine vision systems, as you may be already aware, are the systems which are used mostly in the manufacturing sector, where they want to detect some problems in a manufactured unit or in a manufactured product. So they use the machine visions there to find flaws in there. So it's like they have replaced the human. So which the flaw that can be actually identified by a human eye. So they have generated the robots which actually are taking care of this part. So we are not concerned about it. Now on the communication capabilities, now there are a lot of technologies already available there, like we have AllGen, we have REST APIs, CoAP, XMPP, and MQTT. So all these technologies are already there, which give us a way to communicate with each other. Not we in the sense, the things. It gives the things capability to communicate with each other. But the condition is that both of them have to understand either of the technologies. So not actually one of the, so let's say AllGen is there. So both the things have to understand AllGen. It's like if I'm speaking to you, so both of us should understand English. But if I use my native language and you have your own native language, we cannot communicate with each other. It is something like that. Now after that, so again here in this area, there are technologies we are using the existing technologies for our implementation of the reference architecture. Now then we have, this is the area where we are actually working in our reference architecture, which is our interoperability. How we make systems to interact with each other, which are using different technologies. So this is in that we are taking care of what we say AAA is authentication, authorization, and accounting. So because we need all these aspects in our IoT solution. So and provisioning is very important. All of us you should know that provisioning is one of the major challenges in the IoT, as I have brought up earlier also. And then the inter-system capabilities, again, that two different types of systems actually are able to communicate with each other. And cloud, edge, fog, optimal work. So by that we mean to say that how this MTM layer, which was a constraint network, is talking to the unconstrained network, which is the cloud. So how do you optimize the flow of data from these two different layers? So that's what our architecture is actually trying to address by having fog or edge clouding, or sorry, edge programming, or sorry, edge caching or fog computing. Then I'm saying then there's a security, and also security. Now what we want to stress here is that security is where from we start. So when the framework which we are building, we are making sure that it is very secure. it is very secure. It is really very secure. So this is where we take care of it. Now, this is the GlobalLogic's view of embedded systems, IoT, what we are building in our framework. So as I said, the security transport is the base, is where from we start. Now we have a secure transport layer. We are not inventing any new layer. So we have the TLS and SSL based security transport layer. That's what we are using. I think they are tried and tested, and let's use that. Let's not reinvent something there. Then we are having a plug-in approach for these technologies, which is all join MQTT, REST, or any other technology that we have. So the way we have implemented is that we have a communication agnostic framework in place. So our implementation does not. It's a plugin, so it can be anything. So whatever you put, the framework, the implementation is supposed to work. Then capability negotiation is again what we say interoperability. That's where we are working. Because if you have multiple technologies, we need a layer in between which will communicate them. So there's a translator in between. If a all join is coming there, and then there is a SOAP request coming, a co-op request coming, so they need somebody who can translate this information. That's where we are working, these areas. Because these are the challenges actually. And then we can also do we are trying to, on the MTM side, for effective or for high performance delivery of the data, we are doing some if this then that kind of rules. We are applying very simple rules, and we are doing some kind of computing. As I said, we are introducing fog computing, or we are introducing what we call edge caching and stuff like that. And the data flow is that. And the provisioning is actually everywhere. Now there are some technologies which do support some kind of provisioning, but they don't support. So what we are making sure that we are trying to make sure that the technology which don't have an inbuilt support for provisioning, we introduce the provisioning support for them also. Now, just a quick 2 slides after this. How much time we have? Just 2-3 minutes more, okay? So now we have definitions. So if you see here, now we have these are the devices. No, these are not devices. I will say these are sensors or actuators which are connected to the controller. And then we have these are the gateways, which we talk about MTM gateways. And then we have the cloud solution here. So what we have shown here is the various topologies which are possible through which sensors can be connected to the controllers or devices. And so I will skip this definition now because now let's talk about provisioning. Now how we do the provisioning here. In the provisioning part, we know already there's a device, there's a controller, and there's a gateway. So this is the MTM space, and this is the cloud space, this gateway platform. So this is the cloud. So in our provisioning, you can see that everything has to be provisioned, whether it is MTM gateway, whether it is controller, or whether it is the sensor. So everything has to be provisioned before we start communicating with the cloud. So this is so we have a multi-tier security in place. We have a security at the control layer, we have security at the MTM level, and we have security at the gateway level also, which we may be touching later. So when I was looking at, we have a 4-tier security in our architecture right now. Now, if you say how it is, basically the way now if you talk about AAA, which is again authentication, authorization, and the accounting. So in that again you can see every request which goes to us has to come from an authenticated device. So before a request comes to the platform, it has to be authenticated. It has to come from an authenticated device, which has been provisioned in the previous slide I just showed. Now so if a request takes a path, a controller, an MTM gateway, and the gateway, we have a concept of URI, resource URI. So what we do is that we make sure that the whole path is actually being secured. So so if you have a device, or you have a device which is part of this controller, and somebody takes out and puts part of the second controller, no, you have to provision it again. We will not allow it because it is supposed to be registered with this path. It's how we want to secure. Yes, there are other ways, exceptions where we handle it in a different way, some cases where we allow it to do, but this is ideally what we are doing. So everything is secured in this case. Okay, I think, so this was about M2M and the overall architecture of the system. Now I will request the Biju to come and explain the cloud part of it. So Biju, who is our director of engineering, please.
Thank you, Suhail. It's like how we run the Scrum meetings now. Generally the Scrum is for 10 days. For the first 8 days, the developers will keep on developing, and by the time the first drop comes to the QA, 8 days would have been passed, and the last 2 days and the QA has to scramble. And Suhail, same way, he gets passionate about when he talks about his architecture and took away a lot of time. So I'll just make sure that I'll live up to the time so that you guys won't be late for the lunch. Okay, so I'll start from where Suhail has stopped. We just have this reference architecture, and he just talked about the M2M part of it. Now let's slowly start moving one by one. My part is to cover the platform core or the cloud. If you look at this architecture, what is that, the thing which you see it? You see that there are a lot of different kinds of sensors all around the place, talking different languages. They are bombarding the data onto the cloud. Okay, this is like how a UN meeting is going to happen. Everybody talks different language and everything is come to the cloud. What do you need? You will have heterogeneous data coming into picture. That's your first challenge you have to take care. The second thing is large volume. I don't need any explanation for that. Next is near real-time processing, which needs to be done in the cloud, which Jim as well as Suhail has mentioned. Security, security, and security, the third one. And the last is the notifications. You need to notify everybody once there is something has to be done. So let's talk about the first thing. What is heterogeneous or the different languages? People keep talking about it in the previous talks about this heterogeneous or the different languages. How do we solve this? One way to solve is to build gateways. It's an existing way of solving the problem. You build a gateway and you make sure that you connect everything into one single language which I can understand or the cloud can understand. So you build gateways which can just transform these different kinds of languages into single language. And this particular gateway which is built in our system is a custom built one. There's no standard which is being used apart from certain inter-exchange protocols like Apache Thrift, Avro, Protobuf. No, we have not used all of them. We have used one of them. These are some of the reference inter-exchange protocols available for you to implement these gateways. Apart from converting from different language to one language, what are the other things, basic things which this gateway does? It has to apply certain basic rules onto it. For example, let's assume that in this particular room, there's a temperature sensor kept. And you are getting a temperature data as, say, 200 degrees Celsius. Without even, with the common sense itself, you know that if I get this data into my analytics system, my predictions are going to go wrong. Does it mean that you can just ignore the data? No. You might want data to capture the erroneous scenarios as well. So you need to apply some basic rules at the gateway itself. Then, of course, you need to cache it to some extent to aggregate it. And apart from the points which is mentioned in this slide here, you have to do a bit of, not a bit, you have to do authentication and authorization as well in the gateways. We got the data all the way up to the gateway. We converted it into one language. What next? The large volume is coming. That's our next problem to solve. How do we solve it? We need to make sure that you don't lose any of the data, and you need to cache it. Okay? So it has to be fast, it has to be scalable, it has to be durable, it has to be distributed so that you don't lose the data at any point in time. And to manage large volume solutions, there are a lot of queuing mechanisms or caching technologies available. And some of them, just to give you a reference of what are the kind of technologies which you can use. I've put in ZeroMQ, Apache Kafka, RabbitMQ, etc. out there in the mix of technologies which can be used to solve these particular problems. Coming to the most interesting piece of it, the near real-time processing engine. Near real-time itself means low latency, which means that the event comes, you need to have your processing done on that very fast. If you look at it, there are two things required in this particular area. One is you have the streams of data coming in. You need a streaming processing engine. And the second thing is you need a rule engine, which can, or complex event processing engine, which can actually process these events and make sense out of it and take decisions quickly. So this particular component is built of two different technologies, two different kinds of functionalities required. And to build the first set, which is the streaming solution, the technologies available in the market, or these are some of the technologies available, Apache Storm, Spark Streaming, VoltDB. These are the things which can be used for streaming solutions. And for event processing engine, you could use Drules, which is very popular, though it may not be that efficient in this particular case, but it's very popular. You have CD, Esper, there are these technologies which could be used for your complex event processing. When I say complex event processing, the first thing which comes to your mind is that, what is this? What do you mean by complex here? Does it mean that your data structure is very complex? You have 100 elements? No. It means that your events could be correlated with multiple other events to make sense out of it. That is the way you meant by complex. It's not the voluminous of the structure, but the context awareness of the structure makes it complex. And that's the reason why you need to be careful about when you choose your solution. And the most important point of the NRT in IoT world for me is dynamically you should be able to change the rules at any point in time, because your context keeps changing from one to the other, which means that the kind of rules which you need to apply will be changing. Okay, so you should be able to choose a solution which is you should be able to change the rules dynamically without bringing the systems down. So these are the few things which you need to keep in mind when you design the near real-time engine. Coming to the last point which I mentioned as a challenge, the security solution. In this particular platform core, how do you manage security? Or the first thing is privacy. How do you manage privacy? Assume that Suhail was talking earlier, and Suhail may not be interested, Suhail doesn't want to share all the information what he has with me. Similarly, I should not be able, I should not get all the information of what Suhail does. How do we do that? The same old technologies which we have used. Use multi-tenancy, logically separate this data into two. Does it mean that I don't have access to any data what Suhail has? No, I should be able to share some data what I want to share with Suhail as well. That makes it, that's one of the considerations which you have used to make sure that ours is multi-tenant. At the same time, tenant can also share information, what is required, what is authorized to be used. The next is apply the security policies before even you process the data. For example, you are getting a stream of data which has a credit card information. If you go to store the credit card information onto your data store, you just cannot keep the data out there. Your infrastructure should be supporting that. If assume that you don't have that capability in you, what do you need to do? You should be able to discard that particular data and store the remaining part of it. So you should be applying your security policies before you store the data onto the persistent data store, whatever you have. And in-memory processing for non-persistible data. It doesn't mean that you can't process that data. You can process it, but it should be only in memory. You may not be able to persist that data for your further processing. And the last thing is that the transport. When you transport the data, you make sure that you have a secure transport layer which can actually transport it securely. If you look at these things, there are a couple of things which you might strike out from the security point of view. One is I'm not talking anything about the network security. I'm not talking about infrastructure security where this whole solution is hosted. We purposely took it away because that is solution specific. Whatever we have built is an architecture, a reference implementation which can be used for any kind of solution building, and infrastructure security and the network security based on the kind of applications which you build, and that would automatically built into it as you build as a part of the solutions. I'm at the last slide, and the GloMart use case which we were talking about earlier, where the sensor is sending a lot of data from all around the place. It comes to the gateway, which converts it into one language which everybody knows. You cache it or queue it. Then you get into the near real-time engine where it gets processed. The near real-time analytics as well as the complex event processing have been taken care. Then you get notifications. Notifications is that that is the one which is used to the external world to notify that there is something which you need to take rules. And after you apply your rules, the security policies, you store that data, give the data for deep analytics as well as for batch analytics and for storing into the analytics engine. With this, I would like to welcome my friend Bhaskar, who is going to tell you how you can get a needle out of the haystack, the analytics guru. Bhaskar.
So analytics, right? So we have been doing analytics, since ages. So So before that, I would just like to highlight the kind of things that I would like to cover is historical information as well as the deep insight. These two areas I'm going to cover. Okay, so analytics, right? So as I said that we have been doing it since ages, and the analytics is used, for better decision making and to have quick insight over the data. So now, you must be aware of all the 3 V's of big data. So that's volume, velocity, and variety. So what's the difference now that we have been doing with respect to IoT? So if you look at this slide, right? So this talks about the kind of data that we are dealing with. So earlier we have been dealing with the data that is more of a social data or machine data or log files. But now the data that are coming up is over the streams. So data is keep coming up without having it's like uninterrupted data which are coming up, and you need to do analysis without having persisting the data at any point of time so that you can have the real time analysis on it. So that's the biggest and one of the challenges I would say for IoT analytics, and that's why we have turned the name as IoT-A. So what kind of challenges we are going to face with respect to the data that are coming up over the streams? The first and foremost being the data integration part. So it has always been the challenges with respect to data integration. So we have been developing data warehouses and all the enterprise data warehouses for long, and data integration with so many formats, so many unstructured data, or the kind of RDBMS data that we need to look at. So we need to integrate that as well. So with respect to IoT, there are certain kind of devices that are emanating the data, and along with the data, there are sensors data that are coming into the streams. So we have to aggregate as well as integrate it with this kind of devices, and as I just showed you, right? So there are approximately 200 billion devices that are going to intertwine between each other, and we need to make analytics out of it. So, of course, there comes the key challenge to process, this kind of data which has diversification. It is very varied sources. So, another thing is with respect to the data storage, right? So now we are not talking about terabytes or petabytes of data. We are going beyond gigabytes. So when you process these kind of data, you need to optimally store it so that whenever the request comes, and it should process it within nanoseconds. So that's the real challenge. We need to model it in such a way so that our storage is really able to process the data within a stipulated time. Okay, so this is the heart of the analytics, I would say, that the core engine where we are going to develop the kind of prediction analysis that we are going to take place. So what kind of algorithm we need to make, what kind of group of algorithms we need to make, and then process it, and what kind of data modeling we need to have in place so that we actually cater to the various domains or various business users that are there. And of course, it has always been a challenge to present the data in the right kind of format. You have a data, but if you don't know the way to present it, it's no use of a business here. It's no use for the business users actually. Okay, so this is about the couple of the challenges that I mentioned over here. So let me take you back to several years ago when we were actually working with the RDBMS systems, right? And then with the onset of social media and all the other media which have unstructured data coming along, so we face similar kind of challenges. If you recall, right? So data is coming along in an unstructured way or a structured way or semi-structured. But how do you process it actually? So life has actually come to a full circle now, if you look at it, right, with IoT in place. So at that time, people were really struggling to scale out their technology because most of them were using RDBMSs, right? So with the invention of columnar databases or with the invention of Hadoop framework or the similar kind of architecture, you see how the companies like Cloudera or Mapr have really come along. and they are very stable and giving you the platform where you just need to provide your data, and all the things are done by them. So similar way with respect to IoT, there comes a architecture or a framework which handles the kind of challenges that I just mentioned with respect to the kind of data that we are actually ingesting from various devices in the form of data streams. So if you look at it, right, so this is all new data which are coming into the streams, and that's continuously coming up and ingesting it. So we are pushing the data between two layers, that is batch layer as well as speed layer. So these are the main two components where we are actually storing the data. So with respect to batch layer, so batch layer is nothing, it's just a Hadoop framework based on SDFS. And what exactly we do is, so this has two characteristics actually. So we normally add up to the master data set, and we don't modify any data at any point of time. So with master data set, we develop many views which are required to process for apps or any kind of BI reporting. So how different it is, I'll tell you. So we process these batch view overnight. So suppose if you have say 5 years of data, we process this overnight, and then you make a batch views out of it. So we have the data which is into serving layer. So serving layer provides the low latency with respect to the response of the data. So serving layer, the batch views, what it does is, it indexes the batch views so that we process the data in a quick manner. And how, so with respect to speed layer, right, so this is all the new technologies and new framework which are in place right now to help data stream comes into picture. So it's with speed layer, we have like in-memory databases or Spark streaming that we just spoke about. So overnight we process the data and put it into batch views, and from that point onwards we have the speed layer which takes care of rest of the data. So at any point of time we do not store maybe some hours or maybe a days of data in the speed layer. So the best part is you can do predictive analysis on batch view as well as real-time view. So you can have these two views at all the time, and it's a low latency data. So whenever the query response comes, so it can either merge from the two views, or it can process directly from the real-time views. So with respect to GloMart, so the best example would be there is a truck which need to follow certain temperature at all point of time. So we keep running our predictive analysis algorithm. So we have used linear regression with respect to predictive analysis. So we run this on the speed layer for now because the response has to be quick. So what exactly it does, we keep running it and keep poking the data which is 30 minutes prior to what exactly is now. And then we predict that, at what point of time the temperature will go beyond 50 degrees. For example, if the compliance level is 50. So we predict the data from the real-time views and then make a prediction logic into it and then deliver it as soon as, it reaches prior to 50 degrees Celsius. So this is about the technology stack, what kind of technology choices we have, So these are the components, I would say, the batch view, the real-time view, the consolidated view. If you need to merge the query from both the views, you can have consolidated view as a serving layer. The analytics engine, which I talked about, you can use R and Mahout, and you can use the prediction algorithms out of it. The real-time machine learning is, again, Spark ML. So Spark ML is the new stuff that is coming around. So if you need to process the data that is coming out from streams and you don't want to persist it and still you want to do the data mining out of it, so the Spark ML is the best technology to use that. So Spark ML gives the data instantly on prediction, and you can use any type of algorithms over there. And of course, we have talked about Kafka as a data ingestion layer. We are also using it. Okay, so as I said, the analytics part takes care of two things. One is the business intelligence, another is the predictive analysis part. So as I said, I give you the example. So we are actually keeping temperature sensor as one of the attributes to do our predictive analysis. So what exactly happens is if it goes beyond a certain limit, it will send an alert to the platform or to the apps that this temperature is going beyond compliance and you have to act on it. Okay. So as I give you the example, like several years ago, how Cloudera and all the other companies have come up, and they are really stabilized right now, and to give any type of big data solutions. So now people looks like have jumping on the bandwagon. How? Look at the Informatica stuff. We have been working with Informatica as a pure ETL solution, right? So now they have how they have incorporated the kind of devices, the data streams that are coming up, and into their existing products. So you can still use ETL as well as the stream data using Informatica technology. So this is called Vibe data streams. Another is Power Stream. They used to be analytics database. Now they have implemented IoT analytics framework into them. So this is very interesting. So we have been working, and the GlobalLogic has been working to develop the Lambda architecture. And if you look at it, right, they have exactly doing the same. So if you look at it, right, so this is the kind of real speed layer, I would say. It's an in-memory database, VolDB. Another is the Hortonworks, which gives you the platform on big data. So this is a batch layer, and how they are merging the data and giving you the insights of all these data in a low latency manner using various BI tools like Tableau or any other MicroStrategy tools. And from this point, you can access your data using any mobile devices or any kind of devices or the apps, which is going to be the next session that my friend Manu Sinha is going to talk about. He is a principal architect, and he's going to talk about the apps thing.
Okay, so all of my friends have spoken to you about how exactly the platform is working, right? The difference becomes that in applications, we have to be solution specific. We can't really define an application as a complete generic solution. They have to be very specific to a special cause, and for example, in this case, we've taken GloMart. So when I'm designing GloMart, I actually have 5 different applications I need to design. I need to design a truck app, I need to design a driver app, I need to design a store manager's app, and all of these will have similar functionality, but the views will be slightly different, right? So what are the challenges that you face when you start talking about apps and IoT? So, Apple has started out very clearly by saying there's an app for that, right? And if you've seen recently what Google has also said, which is very similar to what Jim said, which is that the brain layer is disappearing and becoming part of the background, right? Now, apps are not really part of the background. How do you actually work when the app is actually also being part of the background? Where will that happen? How would that work? So, first of all, you have a very rapidly changing ecosystem, right? PCs are now the past, mobiles is the present, while wearables are the near future. Microsoft released something called HoloLens recently, which was an amazing leap forward. But again, what exactly is going to happen in the future? Nobody knows. You'll have to be able to handle apps in all of these systems. Very high fluctuation, right? So you would have apps that would basically be used once a month. You would have apps that would be used multiple times a day. You would have apps using multiple times an hour even, right? So the variances and the actual variance that is there is very, very high. And any kind of app that you have to design, you have to figure out whether you're defining it for what kind of audience and for what kind of purpose. You also need to design apps for all types of use cases. We had a pillbox. We had basically defined definitions of a connected home. You have an aeronautical aero engineer being informed about when their engine needs servicing, right? You'd also need IoT for forecasting. The first IoT actual worldwide application was created by NOAA when they actually did this early warning tsunami warning system, right? Where they actually put all of the sensors on waves to predict how high they are. So therefore, they could actually say when a tsunami is going to come. So if you look at what kind of an app will you build for that? You also have a completely new UX paradigm, right? So you have farms, the new farms that are going to be there. You will have to take decisions about cows, for example. How would you make your app talk to a cow, right? How would you actually make horses understand it? How would you be able to handle UX in a moving car, right? All of these are actually changing the entire UX paradigm as well, and apps will obviously be the place where that will be solved. Even in nowadays with TVs, you're going to have apps coming in, right? Apps are already there for TVs. But in actuality, the entire UX for TVs will also change. The TVs itself are changing as well. If you see the world today, in 1942, we had the first one computer, right? And then in the 1980s, you had around 1 million when Microsoft started out with their personal computers. Moved on to phones, and now in 2010, we have around 8 billion devices or so. And in 2020, the assumption is anywhere between 25 to 50 billion. So it's a natural evolution where we'll actually seeing IoT as just a natural evolution of that. So whatever technology we suggest or whatever we actually are doing, it's actually becoming much more mature as we go along. Nothing is there that is actually completely new, but they're also maturing and becoming slightly different ways. A .NET application written in 2001 versus a .NET application written in 2015 is very, very different. But the technology is the same, right? And the other part is, in Jim's presentation, we saw that application lifecycle for a phone is around 18 months. But in actuality, there's also chances now of a phone or a fridge or a ship. The life cycle of these kind of applications are going to be 30 years. An application has to be able to be comfortable with that legacy. We'll be able to handle these kind of use cases as well. And a lack of a default standard. I think we've spoken quite about this, so I'll move on. So with these challenges, right, what is the best solution? And the best solution is to build applications on an IoT-specific application platform. So how would we go about doing something like that? What is an IoT-specific application platform? So plenty of platforms already exist. Some of them may be names that you may not be aware of or you may not have heard. Xively or Numbo or ThoughtWorks have just been around in the recent past. But they're actually all doing ingestion and analytics, right? We want to take it a step forward. We want to say, what else can you do? So we're talking about now building an app platform. Well, application platform has to be built with some of these features. So I spoke about the challenges. Take a look at a usage of something like an auto-update feature, if like Google Chrome. Now, if you auto-update all your apps, then you'll be able to handle legacy as well as future systems. If you have a plug-and-play approach for building applications, you should be able to handle a new paradigm as well as handle all types of use cases. If you have cloud and cloud patterns, you would be able to handle difference in consumptions. If you handled ability to integrate with existing systems, then you should be able to handle the rapidly changing ecosystem as well. So on and so forth. Basically, what we're trying to really say here is that this is the kind of feature sets that an app platform would require and be able to handle, right? And what we really want to do is actually build once. So let's take an example of an iOS, right? If you start building an app in iOS today, you have two choices. You would use Dart, right, or Swift, sorry, or you'd use their old system, their old Objective-C. What would you use? Probably you would want to build an app in both, right? So you would actually have the ability to abstract out, ability to actually, how would I render a view, and what is the kind of data I need to render? Data is coming from the backend. The device would just have an abstraction or an adapter to its view, which could be written either in Objective-C or in Swift. And therefore, you'd be able to build once, reuse anywhere, and you continuously update it. So when iOS releases a new version of it, I just update what I already have. Now I have two versions. I have the Swift version 1, and I have now the Swift version 2. And based on the capability of the device, I can now fit it with whatever I want. So that allows us the ability to actually being able to reuse it multiple times across the way. You'd also want to follow the rapid application delivery model. We've talked about this, I've changed it a little bit. It used to be rapid application development, but it's now actually about delivery, because what we have realized, especially with Apple, is that unless you actually take design and delivery as part of the process, right, and actually make it into one, it's not just about the developers anymore. It's about the entire process. So you have terms like design-led engineering, you have terms like, how would you actually do continuous delivery across that? And so therefore, what we're really saying is that the model that you need to follow is actually going to be a new one, where it's going to be a rapid application delivery model. One of the interesting things that we also had recently is when we spoke to a company who's a pure IoT-based company, is that they said they have 12 parameters to decide whether they'll work with a company or not. And one of the parameters is the ability of that company to handle change. And so what they meant is that, for example, a traditional retail shop would have a separate offline and a separate digital world. And these departments would not really talk to each other. That's not really possible in an IoT world. Whether the company is actually willing to change that is basically a definition of whether they'll actually be able to work with this company to make it actually successful. Because the amount of money that you're going to be investing into IoT is going to be pretty high, right? So that is obviously something that has to change. This is one of the proposed, so this is the proposed architecture of the application platform that we're building out. One of them is you have multiple types of apps. You would have the app renderer, which basically handles the rendering of the data. And you would have the engine SDK, which connects with the API to get the data, right? So the API is actually on the cloud. You would have an orchestration manager with workers which basically handle the actual data and on the workflow. You would integrate with third-party systems via ESB, and you would have application-specific databases here. You would also connect with the platform, which my friends have developed using data with Bhaskar's analytics services come here, Biju's data services comes here, and the streaming service and config services come here. And this is basically the custom, the tech stack. So if you look at this, you would build this custom built for each stack. You would use this as a mixture, which may or may not be there. And you would basically build the API in Web API or Node.js or Vertex. You would use Polyglot DB for the application development. The workers would also be polyglot programming, because you would actually want to build workers in multiple ways, right? If you're comfortable with PHP, you should use PHP. If you're comfortable with C#, use C#. That's not something that should stop you from being on the cloud. And so on and so forth. And the integration ESB would just be a normal enterprise service bus. So how is GloMart going to be built on this platform, right? So all views would be built using a data format and a type format. I've already explained that. Basically, they connect up with business logic, right? These business logic needs to be built as workflows and then broken down into atomic tasks. These workflows provide the right context. But what I mean by that? So we've talked about this use case where the truck is going along and now it's carrying apples. How does it know it's carrying apples, right? Is there a sensor that tells them that? The context that's carrying apples and the context that apples have to have a temperature between 12 and 18 degrees Celsius is something that the app platform provisions into the platform. And that's how you'd actually set up this, right? You would then use events. So for example, as soon as the temperature is going out of compliance, that should come over to my end and I need to kick off a workflow. Those workflows could again be different, right? The ability for me to send out emails or phone calls or alerts or emails or anything of that nature. And then I should be able to respond back and say that, okay, we've got this. So here is my data. I have integrated with my platform with the third-party, GloMart, which has its own inventory management system. I pick up data from there and I say, what are the open jobs? I have this data which requires these apples can also go to this place, which is 2.5 hours away. And then that I need to send back into the platform. So there's a two-way communication that has to happen. And the platform is basically, as I said, is also responsible for integration, right? So this would be the way we kind of go around building an application that is specific for the solution. So as you can see, we've taken the paradigm that we had earlier, and we've basically spoken about how all of them work. And at the end, what you really see is that the app platform is really like the hand of God. It's kind of sparking life into the machine. So in conclusion, what I'd really like to say a couple of things, right? So if you think that internet has changed life, IoT is going to change it again. It's going to completely redefine life as we know it. So we've covered up all of the different parts of the reference architecture and platform. So in summary, I'd like to invite Suhail. Suhail gave a brief overview about what IoT architecture was about. He also gave you an overview about he forged a path about how to go about designing IoT solutions, what are the considerations and architectural considerations that need to take place. He also proposed a solution around how embedded devices need to work around in IoT. We also learned about provisioning and authentication. Biju has spoken about what is the brain of the IoT platform. How would it work, right? He's spoken about how the different data formats will be pushed into one format. He's spoken about the architecture, design, and the technologies behind the polyglot database and the speed layer. Bhaskar, he's spoken about what IoT analytics is about. He's also given you an overview about Lambda architecture. He's also given you the use case about how that was solved, as well as explain the technologies involved. And I am Manu Sinha. I spoke about how you use and architecting IoT apps. And at the end, I'd like to add this. While we spoke about just this as one paradigm and we used one use case, Jim spoke about Uber, we spoke about Glomar. The same paradigm can actually work across a multitude of problems, right? Whether it be retail, whether it be healthcare, smart cities, anything. We found this, we actually came up with this paradigm because of the fact that we actually saw this solving all the problems that we did. So it was more of a reactive discovery rather than an intuitional one. And I think it was a great leap of faith from Jim to actually come up with this and explain how this all worked. So we would like to now open up the floor for questions. Thank you very much for listening to us.